This video is on the bioanalytical technique gas chromatography mass spectrometry. In the field of forensics, past cases have included an individual getting pulled over and detained for having illegal substances in their possession. It is not uncommon for blood to be drawn from the suspect and used to determine if the individual had drugs in their system at the time. When a person consumes a drug, the liver metabolizes the drug into a different substance called a metabolite. Once the blood sample gets to the forensic lab, it is subjected to a number of tests by trained toxicologists who specialize in forensic toxicology. It is the analyst's job then to determine what substances are present in the blood sample. This is done through a technique called gas chromatography mass spectrometry, which is very important in the field of forensics. Once the blood is extracted in the proper solvent, mass spectrometry uses a beam of electrons that causes the molecule to break apart into smaller fragments. Molecules always break apart in the same way due to their chemical structure, and this can be mapped into a spectrum and compared against a database of known spectra. The purpose of this technique is to identify molecules and metabolites by measuring mass-to-charge ratio, which can then be used to calculate exact molecular weight of the sample components. Gas chromatography mass spectrometry is a bioanalytical technique in which molecules are converted into ions, which are separated based on their mass-to-charge ratio. It is useful in determining the abundance of isotopes. This instrument performs four major functions: production of gaseous ions, acceleration of ions in magnetic or electric field, separation of ions in mass analyzer, and finally detection of ions based on their mass-to-charge ratio. A strong vacuum pump is required in the instrument to prevent the charged ions from colliding with air molecules and not reaching the detector. Electron impact ionization is when a stream of electrons is generated by using a heated metal filament, seen here. The other end of the chamber has a positively charged electrode right here that accelerates the electrons. It is important the energy of the electron is 70 electron volts because this increases the probability of electrons hitting the molecule under study and breaking the chemical bonds. The sample is vaporized and introduced into the sample chamber here. The high energy electron collides with the molecule and breaks it into smaller molecules. As the electrons are released, the fragmented molecules are left with a positive charge. A repeller electrode with a positive charge accelerates the fragment right here, and the analyzer is composed of a curved magnet and a detector at the bottom. As fragmented particles travel through the magnet, they are separated based on mass-to-charge ratio. Once ions are separated, they are detected by the detector and creating fragment patterns in terms of a bar graph. Each molecule has its own distinct fragmentation pattern, and obtained patterns are compared to a known standard for identification. Results from a mass spectrometer look like this. On the x-axis here, there is the atomic mass, and on the y-axis is the relative abundance. These results indicate a zirconium atom, which has the atomic mass of 91. The different isotopes are shown here, and the most abundant isotope in the given sample has a mass of 90, as seen here. Like any technique, there are pros and cons to mass spec. Some of the pros include it is very sensitive and detects in parts per million. Additionally, only a very small amount of sample is needed to run the mass spec. One more benefit is it can help lead to a suspect's conviction when used for forensic analysis. Some of the cons include these instruments typically specialize in one class of chemicals, so they cannot be used outside of a specialized lab setting. And they are expensive and bulky, costing up to $500,000 or sometimes more. Also, they cannot accurately identify hydrocarbons that produce similar ions, and they are unable to tell optical and geometrical isomers apart. I think this is a useful technique because it allows scientists to identify unknown substances, which is not only important for forensic, but also other fields of study. It can be used for environmental purposes such as testing water quality and soil analysis composition for analysis of pollution. In the pharmaceutical field, it is used in drug discovery and metabolism. Overall, I think mass spec has a positive impact on the overall scientific community. The future of mass spec is heading towards a more portable technique, meaning analysis will be able to take place outside of the forensic labs. This means analysis can take place at the scene of a crime, for example, minimizing room for error in sample transportation and storage. Overall, mass spectrometry is a beneficial technique in the field of science.